This is the second video lecture for our one-way analysis of variance lesson. In the last video, you learned why one-way Anova is preferred over multiple independent t-tests, and you learned some basic concepts related to one-way Anovas, such as the F distribution and the hypotheses that are used. You were also introduced to the Anova source table and pairwise comparisons. These are the learning objectives covered in our Anova lesson. In this video, we're going to focus on the last three. I'll show you how to conduct a one-way Anova in Minitab Express, including running Tukey's pairwise comparisons tests, and we'll interpret those output. These are the steps for running a one-way analysis of variance that I got from the Minitab Express help guide. You can see that the steps are the same for a Mac and a PC. The example that I'll be working on here will use data from the Fall 2016 student data set. These data were collected from an anonymous sample of World Campus Stat 200 students at the beginning of the Fall 2016 semester. Students were given a survey, and these are their responses. For this example, we'll use the height variable. This is height measured in inches, and drink preference. Drink preference was a categorical variable. Students could choose between beer, wine, or neither. Before we can run a one-way Anova in Minitab Express, we first need to check assumptions. Minitab Express does not automatically check any assumptions for you. You need to do this on your own. Recall that we had three assumptions. First, that the groups are independent. That assumption is met here because we have three groups of different people who are not matched or paired in any way. The second assumption is that the population distributions are normal. To check this, we can construct histograms or dot plots for each of our three groups. I'm going to construct histograms with groups. Our Y variable, or response variable, is height, and our group variable is drink preference. We get 4 histograms. 3 of these are labeled with different drink preference options. The 4th histogram, the one on the upper left, is not labeled at the top. This is because this case did not answer the question about drink preference. This is missing data. This individual will not be included in our analysis of variance. We just need to look at the histograms for our 3 groups. Remember that these are histograms from samples, so they'll not be perfectly normal. At this point, we should just confirm that they are not terribly skewed or non-normal in some other way. These 3 histograms all look okay to me, so the assumption of normality is met. The third assumption is that the population variances are equal. Again, we don't have the populations, we have samples, so we'll need to compare the sample standard deviations. We can obtain the standard deviation for each group by running descriptive statistics. On a Mac, this is statistics, summary statistics, descriptive statistics. If you're on a PC, it's just statistics and describe. The variable that we're interested in is height, and again, our group variable is drink preference. Under statistics, we can see that standard deviation is one of the default descriptive statistics selected. We can uncheck the other boxes because we don't need these statistics at this time. The standard deviation is largest for the neither group and smallest for the wine group. The largest standard deviation divided by the smallest standard deviation is 4.5997 divided by 4.2267. This equals 1.088. This ratio is less than 2, so the assumption of equal population variances has been met. All of our assumptions are met, so we can go ahead and conduct our one-way Anova. In Minitab Express, I'll go to Statistics, Anova, one-way Anova. In this case, our responses are all in one column for all factor levels. This means that we have one column with our response variable of height and one column for our factor of drink preference. The other data entry option here is that responses are in separate columns for each factor level. That would be the case if we had all of the heights for beer drinkers in one column, then all of the heights for wine drinkers in a second column, and all of the heights for those who selected neither in a third column. But in this case, our response variable and factor are in different columns, so we use the default setting. We tell Minitab Express that our response variable is height, and our factor is drink preference. Under comparisons, we're going to select Tukey. Of the options here, Tukey and Fisher will make all of the possible pairwise comparisons. They're just different in how they control for multiple tests. Dunnett's test will compare different treatment groups to one specified control group, so it's not making all of the pairwise comparisons, just comparisons between control and treatments. And Sioux will only make comparisons with the best group. But Tukey is the only option that we're going to be covering in this class. We click OK to get our output. Minitab Express is going to give us a fair amount of output here. Let's go through each of these tables one by one. First, Minitab Express will give us our hypotheses. The rows unused are the number of rows with missing data. Recall when we constructed our histograms that there was one person who did not select a beverage preference. Without that data, that individual has been excluded from this analysis. The factor information is telling us that for our factor of drink preference, there are 3 levels, in alphabetical order: beer, neither, and wine. The table labeled Analysis of Variance is also known as the Anova source table. This gives us our degrees of freedom, so our k-1 and n-k. ADJ stands for adjusted, although for a one-way Anova, these are not really being adjusted for anything. These are just our sums of squares and mean square. The F value is our F test statistic. Typically, the F test statistic is reported along with its degrees of freedom. So here we would say that F, with 2 and 521 degrees of freedom, is 17.32. Our p-value is less than 0.0001. This tells us that we should reject the null hypothesis and conclude that the means are not all equal. The model summary table we're not going to be working with. The means table is just giving us summary statistics. Then we have our 2 Tukey pairwise comparisons tables. In the first table, we can look at the grouping letters. If 2 groups do not share a letter, then they are significantly different. For example, beer and neither do not share a letter, so they are significantly different. Beer and wine do not share a letter, so they are significantly different. If 2 groups do share a letter, then there is not evidence of a difference. So neither and wine are both in group B. They are not significantly different from one another. My preference is to use the second table that we're given. I like this table because it gives us all of the adjusted p-values. These p-values are adjusted to take into account that there were 3 pairwise comparison tests run here. As always, if our p-value is less than or equal to 0.05, we reject the null hypothesis and conclude that there is evidence of a difference. Here, our first 2 adjusted p-values are less than or equal to 0.05, so the first 2 pairs are statistically significantly different. Our last pair, wine and neither, the p-value is greater than 0.05, so we would fail to reject the null hypothesis. There is not evidence that the wine and neither groups are different. When you select the Tukey test, You'll also get this plot of confidence intervals. And by default, you'll always get this interval plot of the 95% confidence intervals that were featured in the means table earlier. Let's summarize what we've covered in this lesson. We learned why we need a one-way Anova as opposed to multiple independent t-tests. And Anova is used to compare the means of 3 or more groups because conducting multiple independent t-tests would increase the actual alpha level, making a type 1 error more likely. We learned about the F distribution. It has 2 different degrees of freedom and is used to determine the p-value for a one-way Anova. The p-value is always right-tailed. We saw one example of using an F distribution in Minitab Express in the last video to look up a p-value, but when we're conducting a one-way Anova in Minitab Express, it will give us both the test statistic and the p-value. So most of the time, we won't be looking up these values ourselves. We checked assumptions for a one-way Anova. Remember that you need to check assumptions yourself. Minitab Express does not automatically do this for you. You will need to make histograms or dot plots and judge their normality, and you'll need to compute and compare the sample standard deviations. In this video, we conducted a one-way Anova in Minitab Express with Tukey pairwise comparisons. This concludes the one-way analysis of variance video lectures. The Locke's textbook covers one-way Anova and it introduces some pairwise comparisons. However, it does not cover the Tukey's pairwise comparisons specifically. This is, however, covered in the online notes. As always, if you have any questions, please post them to the discussion board on Canvas.